Hi there, welcome to your lesson on the chain rule. This is a very important rule in the realm of derivatives. It helps us find derivatives when we have a function within a function. Just like the great movie Inception, where we had a dream within a dream. The chain rule helps us deal with functions within functions. All right, let's begin. So we have two functions, f of x and g of x. First, to begin, let's write a new function, h of x, which is the composition of f of x and g of x. Written like this, h of x equals f of g of x. So the g of x function goes into the f of x function, and we create a new one. So it's a function within a function. We're going to see where this leads us to in the chain rule in just a second. All right, so here's h of x. The g of x function, this one, has gone into this one. So we can see here's the g of x function within the f function, so we see this squared. All right, we've created a new one. Now, let's find h primed of x, the derivative of this, using the power rule. Okay, for the power rule, we know we drop down the exponent to the front and then reduce this exponent by 1, so now it's 1. So there we have it. There's h prime of x. We've found the derivative. Easy. I'm going to simplify this a little bit more by multiplying this through now. So multiplying 2 through here, we get this. Great, we have h primed of x. Now let's find the derivative again, h prime of x, but this time let's begin by opening the parentheses. In other words, multiply that out by itself. So here it is written like that. Now let's multiply everything through and simplify. So there's h of x. This is still not the derivative, but now we have a simplified form of that. Let's take the derivative of this using the power rule. So h prime of x is 36x cubed plus 12x. Now, over here, we have multiplied everything correctly. We've taken the derivative using the rules we know correctly, and we get this. But over here, we got this derivative. So something's wrong. They should match, right? We can't say h prime of x is this, and they're different. So which one do we know for sure is correct? Well, there's no flaw in what we've done here. Expanding this and then taking the power rule piece by piece is something we've looked at already. That works. That means there must be an error here. So what's the error? Let's take a look. Well, first of all, when we applied the power rule on this and dropped the 2 down, we kind of forgot that there's this function inside a function. So we're doing the outside by doing power rule, but within there we have this function. So check it out. That is actually not h primed of x. It's actually h primed of g of x. We've taken the derivative of the outside thing, the function itself, but we've ignored that there's a function inside. So now we're saying, hey, there's a function in there. So let's write the derivative like this. So that means that's that as well. So this is not really h primed of x. Now check this next step out, because this is the key part of the chain rule, which is what we're looking at today. I'm going to take the derivative of g primed, which is the one that's sitting in here in red. So this, sorry, of g of x. So here's g of x, and I'm taking the derivative of it. The derivative of that is 6x. Now watch what happens, or actually try it yourself. What happens when you do this multiplied by this? What do you get, and what do you notice? All right, when you multiply those two, which is actually this whole thing, h primed of g of x times g primed of x, multiply those two, and you get what we had over here. So this is getting a little complex with symbols here, but let me kind of break it down for you. What we did is, we noticed when we had this, we can take care of the derivative using power rule. Let's break it down. When you look at something like this, where there's a function within an outer function, just to do power rule on the outside and ignore the middle function is wrong. It didn't work. We saw that. So what you got to do is do the derivative of the outside function, which means drop the 2 down, and then multiply it by the derivative of the inside function, because that's what we're doing here. The derivative of the outside function times the inside function, and it gets you the right thing. That is called the chain rule, and that is your big idea. And we'll take a look at it through some simpler examples. So if that didn't quite come together for you yet, don't worry. Let's go forward with it. So chain rule looks like this. Let's say, well, this is not the chain rule yet. This is just an example of a simple derivative, right? We have y equals this, and then y prime, the derivative is this, right? By power rule, we can just drop the 6 down and lower this by 1. That's power rule. But now let's look at that in the context of a chain rule. So here we have a function that looks kind of like this one. Notice we have 4 times the function to the 6th power. Here's 4x to the 6th, but now the x in here has been replaced by a function. So there's a function within a function. Okay, this is simple. This one, there's a function in there. So let's do the outside like we would do here, right? You drop the 6 down and multiply. So drop the 6 down and multiply. You get 24. Lower the exponent by 1. Keep this part here exactly as it is. Just like here, we kept this as an x. Here, we're going to keep this as it is. But what this thing is more than just x. It's this whole other function. So now we're going to take the derivative of that function and multiply by it. That's the chain rule. And that's what we saw happening in the last example, that we need to multiply by the derivative of the inside part in order to get the proper, correct derivative. So this can be simplified, of course, a little bit more. 24 times 15 is 360. There's the x squared, and then leave this part like this because obviously we don't want to expand that to the 5th power. That would be way too big, too much multiplying. So that looks good. All right, so to recap, chain rule. You look at something like this. You have this outside part, which we know the rules for. Power rule, drop the exponent down. But within there's another function. We need to multiply by the derivative of that inner function. Now, if we did not perform the chain rule on here, what would be our alternative? Well, just like in the last one, so let me go back again. In this last one, we looked at it and we said, well, we can just expand it, right? Multiply it out, go like this, and then apply the power rule. And we get there. That's cool. That's cool when there's a power of 2, but what happens like in our case where we have much bigger power? Well, we have a bigger power of 6, so let's say we want to expand this. Well, you would have this huge thing, right? You would have 4 times that thing, times that, times that. It's itself 6 times. That's too much multiplying. But we do know, we've learned about the binomial expansion rule, so we can expand this binomial using binomial expansion, something like this, right? First term plus 6 choose 1, first term to the 5th power, second term to the 1st plus, 6 choose 2, first term to the 4th power, second terms, on and on and on. We could expand it, combine everything, do all that, then take the derivative of each part term by term using power rule, and we would get to the same place as this. Of course, this would actually be less complicated in a way because we wouldn't have this 5th power. But the point is that this can bring us to derivative, but so does this. So why not use the chain rule? It makes things much simpler than having to expand all that out like that. That would be kind of crazy to have to do all that every time. Let's just stick to this shortcut. So now let's look at summarizing the chain rule as a rule using symbols. It looks like this. If we have a function that looks like another function with a function within it, right? A function within a function, then the derivative is the derivative of the outer function with the inner one still there times the derivative of the inner function. And that's exactly what we saw. Let me just show you how that looks, right? You take the derivative of the outside one here by dropping the 6 down and making this 5, keeping the inner one there, and then multiply by the derivative of the inner one. That's what this rule is showing us right here. Derivative of the outer one, keeping the inner function there, multiply by derivative of the inner function. Okay, in your formula booklet, you might see it written different ways. For example, here, it defines one function as fu, and then it says u is actually another function, gx. So this part here is another function. The derivative then can be written like this. Remember, we can use delta y over delta x as one way of showing derivatives. So we have that. The derivative equals derivative of the outside function times the derivative of the inner function du. Okay, so let's go on and use chain rule in another example. So here's another clear example of what's going on. Let's say we had this simple case. A non-chain rule example, but it's an example we know. So here's root of x. The derivative of that we know would be, well, first of all, that can be written as x to the half power. So the derivative is drop the half power, reduce this exponent by 1, which gives you negative half, and that simplifies to 1 over 2 root x, because this x to the half becomes a root x, and because of the negative, it drops to the denominator. So that's something we know. We did not need to use chain rule there because this x, yes, it's a function within a root function, but the derivative of x is just 1. So this is still, in a way, using chain rule, but since it's just x, we using the normal power rule. Now let's look at this in the context of a chain rule. So let's say we had this other bigger function where we have a root, just like we had here, but instead of just x there, we have a function within there. So a function within an outer function. Okay, so now take the derivative. To take the derivative, we do the chain rule. That means we do the derivative of the outside first, so the root function, right? So just like when we did the derivative of the root here, we're going to do the same thing here, right? That root is like a half power, so the half drops, we lower this exponent by 1. Leave the inner function as it is, right? So we're just dealing with the outside function first by power rule. And then by chain rule, we have to multiply by the derivative of the inner function, the one that's in there. So that's 8x. The derivative of that is 8x. So that is the derivative of this by chain rule. The outside function, keep the inner one there, and then multiply by the derivative of the inner function. Great, that is your chain rule. That can be simplified a little bit more. 8x on top, 2, and all of this on the bottom, but the 8 and the 2 cancel to get 4x, and then all of this here goes to the denominator right there. Pause if you need to. It's important that you get this basic kind of chain rule example and feel very confident about it. Okay, try these 3 by chain rule. Remember, if this was just x cubed, if it didn't have this function inside here, if it was just x cubed, you would drop the 3 and have 3x squared, right? But here we have a function within a function, so apply the chain rule. Let's see what you get. Alrighty, let's check our work on the first one, and here it is. So check your work. Of course, I could simplify that a little bit further. I could do 3 times all this and put that multiplier in front, but this is okay. So check your chain rule. The 3 dropped, this reduced to 2. The function within there stayed there, but then we multiplied by the derivative of the inner function here. Alright, next one. Try this one out. And now check your work there. First of all, I'm going to rewrite it with the half power instead of the root. Then I'm going to apply the chain rule. So outer function, drop the half, reduce this by 1, keep the inner function there, multiply by the derivative of the inner function. Simplify all that to get this. Take a look at what happened there. 10x and 2 simplified to become 5x in the numerator. All this here, because of the negative exponent, dropped to the denominator right here and became a root. Alright, try the third one here. First step here, I would say, is bring that root up to the top. Becomes a negative half power. Now apply the chain rule. Okay, do outside first. So negative a half drops down here. Negative a half times 2 is negative 1. Inner function remains there, but then we multiply by the derivative of the inner function here. Simplify all this to get this. The negative 1, negative 3 become 3. All of this goes to the denominator. I think I have a mistake there. This should be a square here. Let me change that. Magically, this became a 2. All right, now that you've got some practice with the chain rule, let's try some more. Try these 2. And now check your work. There's the 2. Red one is this one, blue one is this one. Check your work. Next one, try these 2 here. Check your work. There's the first one, simplifies like that, and then chain rule, simplify some more. Second one, rewrite it like this with the third power, apply the derivative. Did I write derivative? I should. Pause it again. Okay, here you go. So the derivative now is this, and then simplified to that. Check your work carefully. There's going to be a couple more. All right, try these 2 ones. By now, you're hopefully getting a hang of this and it's becoming quicker and quicker. That's our goal here. Check this one, that one, the derivative like this, and simplified. And number 8, I simplified it first, making it a quarter, apply the derivative, chain rule, and then simplify. And last 2, you can do it. First one, there's our derivative. Second one, simplified first by bringing the entire denominator up and making the entire thing to the power -1. That's what happens when you bring it all up. And now apply the power rule and the chain rule because there's an inner function. By power rule, the -1 drops to the front. This becomes a -2. The inner function remains the same. Multiply by the derivative of the inner function. Great, that can simplify to this. Check your work carefully. I took the negative, multiplied it through both of those, and this whole piece went to the denominator. Wow, fantastic. You are a master of the chain rule. See you soon.